All right, welcome to the madness that is Wednesday. Now, as per the plan yesterday, we did the shuffle between install and manage a server from Tuesday to Wednesday. So today, we'll go through session 2's presentation on installing and managing a server. So in here, we'll just talk about the features of DNS, DHCP, and start the Active Directory discussion, and the 3 activities will be based around configuring the actual features. So I don't have any of the command structures in the presentation. What I have them in the activities as per session 1 as well. So we'll go through this like we did the first session, with just presenting the slides, and then in separate recordings we'll go through the actual activities together for those that are interested, with separate recordings, and those will be uploaded as activity recordings. Okay, so the first topic is the domain name system, DNS, which is basically what enables us to use names that we can remember, such as Microsoft.com, rather than trying to remember all of the IP addresses for all the sites that we want to access. And we can do this by creating basically a lookup table, and that's basically what the domain name system is. Now, we type in a name and it looks locally to see whether it knows a translation for that name into an IP address. If it doesn't know, it will send a request out to have that translated. So, for example, if we type in www.microsoft.com, it'll come back with an address such as 2340, 245, 251. And then the machine will connect to that IP address. Okay, because as you know from the networking classes, everything runs on IP addresses. All right, so the most common thing for us to do with DNS is to convert host names into IP addresses, but we can also do a reverse lookup, in that we can translate IP address into a host name. So if we've got an IP address, we can actually use the DNS system to actually derive the host name attached to that IP address. Some other information that can be added into the records are such things as MX records, which is mail exchanger record, i.e. an email address attached to that host name, for example. So we can have a little bit of flexibility within the system to publish contact information and things like that with the activity. So how does DNS work? Well, it basically works along the system of providing 2 distinct services. The primary one is the lookup service. This is where clients request information from a DNS server, typically that IP address translation. Okay. The other one is zone transfers. Now, this is where DNS servers request more information from another server. So basically, when we set up a server, we tend to make it a primary or secondary server within the domain zone. And in the internet, each primary is like a branch of a tree. If you look at the domain name system, you're looking as if it's a root system of a tree. So you've got branches that come down, and each branch point is a primary DNS server. So that server will know all the information about all the systems in that branch point. It'll then refer to other servers in the next branching point down from it. And to coordinate all this communication back and forth, DNS uses port 53. Now, it is used in both the UDP and TCP protocols. UDP is an unreliable best effort protocol. TCP is reliable, so TCP checks to make sure it can talk to the destination, gets an acknowledgement from the destination back and forth for all conversations. UDP is just like sending a letter in the mail. You just drop it in the box and hope it gets there. So if communication fails in the first attempt, so when you try to do a DNS lookup and it doesn't get a response using UDP, it will attempt to translate again, but this time using TCP. Okay. Now, the destination, the server will run on port 53, and your requests are generally running on ports above 1024. So they are dynamically generated port numbers, whereas well-known port numbers are below 1023. So when you're making a query, the source port is above 1023, the destination port is 53. And when the server replies, it's replying from port 53 to that port number that you sent the request from. So it reverses the ports in its communication. So what does this lookup tree look like? So as I said, when we connect from a client, we send a request to a server, and that server will go and request that it be resolved via the primary name server. And that name server will break up the address that is here into the branches. Now, it works from the last part of the URL. So in this example here, we have an AU as the last section. So the primary name server will then refer it to the AU name server, which will have all the entries that are possible under AU. And the next entry is a gov, so we'll send it down to the gov AU server, and then down until it gets to a full listing of the address that you've given. And when that looks at that entry, there will be, in that table entry, it will have the IP address and any other information that is attached to that address as far as the translation is concerned. So if it's got an MX record or whatever else is there, it'll be all part of that record entry. And this is why we say it's like a tree and branching, right? So you can quite easily see what's going on there. Now with zone transfers, the way it works, for example, what is quite common is you'll have a primary server inside of a network with a secondary server outside in the DMZ zone, and they will share information between each other to get requests resolved. It doesn't have to be within this. In this example here, this is how we would set it up with security in mind, so that the internet can't directly access internal DNS servers. We tuck one up in here and basically have a proxy connecting these two servers together. So the primary server basically secondary server gets a request saying, I need to resolve a host, and it'll go, well, I don't have that information. I need to request it from my primary server. And the primary sends back a response, and the secondary says, yes, that's what I want. I want all the information that you can send me on that particular record. And then the zone server responds with all the record information that it has. Now, in that example here, it's using TCP. It doesn't try to do this using UDP at all, because it wants to, because it's talking between two servers, it wants reliable communication. The request is the client. So in this example, the secondary server is the client, so it will be using a random port above 1024, and the primary server will be listening on port 53 and responding on port 53. With the records that can be obtained from within DNS, the main ones we'll be looking at in our activities will be type A, PTR, CNAME. So type A records is the hostname to IP address. PTR is the IP address to hostname, so the reverse of A. And CNAME is aliases to the hostname. So basically, whatever the primary server name is, it can be referred to by other names using the CNAME records, so it will translate aliases to the original host name. And then you've got hardware and software information about the host, where it sits within the name system hierarchy, whether you've got authority over certain aspects within the structure, the SOAs, and unstructured records for additional information can also be found there. Now, one of the things is, if you are in control of a DNS server, you will not have all the records of all the internet available to you. It's just too big. All right. So when you're running an enterprise DNS server, you're only entering records for the domain names that you want to translate back and forth. One of the things you will do is set a DNS forwarder address, so that when a host wants a domain name resolved that is not one of your primary names, it'll forward the query onto another server and let that server do the full query, and it will just wait there for the response. The other thing that is highly recommended for security purposes is, if you're using forwarders, that you set the forwarders configuration line to have the slave augmentation enabled. So basically what the slave does is it limits the forwarding of queries to the specific servers that are listed in the forwarders list. Otherwise, things will time out. Okay, I've sent a query, I time out. I'll just start sending it to other queries. So I'll broadcast it out to all DNS servers that I can reach to see if I can resolve it. So this is where, if we're in a face-to-face class, I would pause and get you to go off and do activity 4, which is setting up some of the DNS features, such as looking at putting the forwarding zone and reverse zone. So forwarding zone, reverse zone are basically the records for type A and PTR, and then the forwarder entry to forward it to another DNS server to make any resolutions that you don't actually control. The next section is our lovely DHCP. Now, we know how to do this on a client. Client configuration is we just do automatic IP addressing, and whenever that device boots up, it sends out a request to get IP addresses. We know this already. So, Dynamic Host Configuration Protocol is what DHCP stands for, and we already know that it automatically assigns IP addresses to the hosts as they boot up. What you may not know is they also can send optional information out to those hosts when they boot up, not just the IP address and default gateway. All right. Without DHCP servers, we need to configure all the devices manually, which is fine on a small home network, but in an enterprise, it's a pain in the patootie. So, your DHCP server should have a static IP address, and it should be patched with all the latest updates, especially the security updates, because it will be attacked. There's no question about it. All right. There are known vulnerabilities for DHCP and DNS and all the other features that we'll look at for servers. Nothing is perfect, so we try to minimize the risks by keeping things patched with the latest updates. You should have your plan, IP addressing plan, already designed. You need to know what your subnets that you're setting up for these pools. Okay, when we set up a DHCP server, we're setting up pools of addressing that can be assigned out to different networks. So we need to know what the subnets are, what the subnet mask is, and in the scopes and exclusions, where basically is the range of IP addresses we're able to assign out. The exclusions are the static addresses that you've already assigned to devices within that pool range. And with every planning document, you should keep a copy of it stored somewhere so you can refer back to it when you come back to do maintenance or updates or anything else that you need to work on. Now, if it's a standalone server, using a local admin account is fine, but if the server's part of an Active Directory domain, you need to use a domain administrator account. So the reason for that is when DHCP is configured in an active domain, it needs to get authorization from the domain controller to configure that DHCP server. So you need an administrator account that is part of that domain to do that authentication with. So what's the DHCP scope? So within the scope, we have required fields, and basically we need to name the pool of addresses that we're going to have. We need to specify the starting IP address, the ending IP address, what the subnet mask is, how long that lease, okay, so when we assign an IP address out to a client, it's called a lease, and that lease is the amount of time that that client can have that IP address set, and that's measured in days, hours, minutes, and seconds. At the end of the lease, we have to come back and get a new lease. So a new request is sent out by the client, and we go through the whole process again. Optional fields are such things as the domain name, where the DNS server is located, what our gateway is. Other options that are quite common to use these days is option 150, which is used to identify the TFTP server that is used by IP telephones or VoIP phones within the network, for example. So if you look into DHCP, there are an extensive list of optional parameters that you can configure within DHCP. But the required one, the pool name, the range, so it's starting and ending IP address, the mask and lease time is the minimum. Okay? If you don't include the gateway, the DNS server, and that, it won't get anywhere off the local network. Okay? Because it doesn't have a gateway address, it can't leave the network. So how does it work? So basically we send, on boot up, the client will send a DHCP discover broadcast. That will be picked up from a DHCP server. And basically it's asking, is there a server out there that can give me an IP address? All the servers within the range will reply with a DHCP offer, which is sent back only to the client. So nobody else sees it, only the client sees it. And you're going, how does this work? It doesn't have an IP address. It's working by the fact that it knows the MAC address of the client. So remember, we use layer 2 and layer 3 addressing. So the layer 3 address is basically a broadcast, but coming back, if you like, it's specific to here because it's using the MAC address for this client and this client only. So in that, it basically says, here's an IP address, here's a subnet mask, and then the gateway address. Okay, and the client will respond to the server that, yes, that looks good, can I use it? Okay, so this is the pre-request, re-request. So actually read it correctly, Mark. Yeah. Tell that I got up way too early this morning. So basically the DHCP request will be sent back out, and in that request the device is accepting the offer of that server. So it will contain all the information that the original DHCP server sent to it. The reason it does this is if there's more than one DHCP server, they all see which address it's trying to accept. The DHCP server then will respond saying, with an acknowledgement saying, yes, that address is still available. It is now assigned to you, and your lease period starts now. Have a nice day. So you now can use that device on the network, and you're ready to go. So, activity number 5. Let's take a break. Go do this activity. Yeah, okay. Coming back. Unpause the video if you're watching on video. Okay, so basically we'll be setting up the DHCP server using activity 5, and activity 5 will basically define the scope of addresses to use in the pool, and then after we complete activity 5, we'll move into setting up the Active Directory for this server. So what is Active Directory? Well, basically it started off its life as a centralized domain management service. But in today's environment, it's much broader than that. So it is a whole range of services that are directory based and identity related. Okay, so basically anything that you need to control who has access to using it can be accessed via Active Directory now. So the server that's running Active Directory domain service is called a domain controller. It is recommended by Microsoft that your domain controllers are not running other services on them, that it is only a domain controller. There are some systems that will interfere with each other if they're all on the one server. Just a heads up there. Plus, it's a good way of Microsoft to sell more licenses for their servers. Alright. Oh, you've only can set up this controller, you can't do anything else. Buy another license. Ching-ching. Am I a cynic? Yes, I am. Okay, so what does a domain controller do? It authenticates and authorizes all users and other devices within the Windows domain. So it assigns and enforces policies such as security within the domain, and it can also be used to remote install software and update software using those policies. So what services make up AD now? So you got the original one, domain services. We now have lightweight domain services, certificate services, federation services, and rights management services. What do they all do? I'm glad you asked that question. See, I'm a mind reader. I know that you're asking all these questions. So domain services stores information about the users within the domain. That can be either devices or users themselves, and basically is used to verify credentials and to assign access rights within the network in the domain. What's the difference with lightweight directory services? Well, industry standard LDAP protocol is a different way of doing storage within different systems, and lightweight directory service implements LDAP within the Windows environment, and it shares that base code with Active Directory and provides functionality and application interface points that conform to LDAP standard. Now, the benefit of using lightweight directory service is it doesn't actually need to create a whole system of domains and domain controllers for this storage solution to work. It uses its own directory service interface to provide data storage directory services. So basically, it controls and indexes where everything is stored within the server and provides access rights and all that lovely thing. Now, the main benefit of running LDS is LDS can run on the same server as other services, whereas domain, they recommend you don't. So a lightweight directory service might be better suited to the type of service that you want to run. Certificate services creates, validates, and revokes public keys. So basically, if you want to secure data using encryption methods, using public key certificates within your organization, you use a certificate service. And this service, in conjunction with other applications and protocols, you can encrypt files, emails, and even network traffic across your domain. Federation Services is a single sign-in service, allowing your credentials to be stored centrally and sent to all devices and applications and services that need authentication credentials. So that basically means a single login. Okay, if you're not using Federation Services, it means each time you go to access a different area of the network, you've got to retype in a username and password. Rights management is where we use a combination of encryption and selective functionality to limit access to documents such as emails and that. And so not only are we limiting who can access these specific files or web pages, we're also limiting what they can do with those files when they have access to them. So it's quite a powerful advancement in management service. Now, as this unit is a total of 4 sessions, we can't go through all the possibilities of Active Directory and the associated infrastructure configuration options that are attached to Active Directory and servers in general. So I've used in the past a series of books that are published by Cengage. Now this one is the 2008 edition. Cengage have the latest one that is published at the moment is 2016 edition. They're written by Greg Tomshaw and basically align with the Microsoft certification exams. So if you want to be have your head around this properly, I recommend you get yourself those 3 books and get yourself certified as a Microsoft administrator by sitting those exams, because each of these books, they're like an A4 book, and you're looking at over 600 pages in each one. Okay, so I'm obviously not going to try to replicate all of that knowledge in these 4 sessions. So if you want to go back and go through and get a really in-depth knowledge of how all the options work, go grab yourself some textbooks and do some study on your own, I would recommend. So activity 6, we're going to cover the basics. So we're going to set up and create a domain controller. We're going to add user accounts, group accounts, set up an organization unit, and add computer accounts, so device accounts. So this is the basis that allows us to control who has access to what, where, how, when, and we'll discuss how you can then assign users to multiple groups, and you can assign groups to security policies and all this sort of lovely meshing of accounts together to provide access to users or groups of users or devices. You get the hint. And that's all for the presentation. All right. Yes, it was pretty quick. I didn't want to bog it down too much with 101 different command structures and that, because we'll do that, as I said, within the activities themselves. Now, from a practical standpoint and a speed standpoint, I'm going to start basically using the PowerShell wherever possible, rather than going through the GUI interfaces, basically because it's a lot easier to create the activities. Okay, if to create the activity sheets with the GUI interfaces, I'm running into activities that need to be 40 or 50 pages in length just to do all the screen captures, which is a bit redonkulous. So activities will be published using the PowerShell commands, and as you should be fully aware, these are derived from our great resource called ServerWorld, and makes all of this accessible to you offline as well, even at this stage when I haven't published all the activities up, because I'm in the state of flux of writing all this new course for you. Because as you know, on My Learning, if you've looked at My Learning, it basically says, okay, here's a whole series of videos, go watch and go do. Okay, so hopefully you'll get a bit better understanding with me going through the history of the various features and what they're doing before we go off and actually do some practical lessons. Okay. Here endeth the presentation recording.